Hi, I was just troubleshooting what I think it is a bug in the ClojureScript compiler, and I was using FlowStorm for it. And yeah, I wanted now to make a video to share how I use FlowStorm in this real situation. Most of my videos are kind of a demo, and this I'm going to share you how I use it to debug a real bug. Let me first try to explain what I think it is about. So if you run Clojure and if you define something like foo here, it will create a bar. You can check the meta of that bar, and you will see it contains a lot of information like line, column, and file. And you can change it. By default, this is going to be 1 because we are evaluating creating this bar from the REPL. But you can change that by providing metadata to this form. You can do like line 42, and now if you check it, it will be like that. Now, let's try to see what happened on ClojureScript. Here, I just clone ClojureScript source code, and let's start a REPL. So we can do that like this, and let's start it with REPL. So it creates a browser REPL. Okay, and there we have the browser connect. Let's try to do the same here. So if we define it like this, and now we check the meta. Yeah, for some reason it's not taking into account the meta we provided. This is why I was trying this, and why I think it is a bug and it's important. It's because tooling can use this functionality, like trying to set meta, because if, for example, if you have CIDR and if you evaluate something from the REPL, not from the REPL but from your buffer, then on your CIDR knows what line something is, but because ClojureScript doesn't have a way, it looks like doesn't have a way of providing the line for something, then every time you reevaluate something from your editor, you are going to lose that information. Which is information that's used by other tooling. Like for example, if you do Clojure REPL source, it will use this information, and probably some other tooling. But yeah, let's try to run this in FlowStorm, the compiler in FlowStorm, and try to debug it. Okay, so for that I have here, this is just ClojureScript debugging. And I added one more alias here with basic ClojureStorm and FlowStorm configuration. So now we can run like this, and we can start the REPL with Storm there, and we can start the UI, the debugger UI. Let's do that first. Okay. Now we have the debugger UI. It's not recording anything, so let's try again our commands here, just to see everything is fine. And oh, sorry, we are still on. I was surprised by this. We are still on Clojure REPL. We need to start the ClojureScript REPL. So let's require CLJS main, and now we can call CLJS main function with the REPL argument. Okay, now we are in a ClojureScript REPL. Let's try again our thing. And yeah, we are still line 1. So let's try to run exactly the same, but let's record what is happening. I when I was troubleshooting this, I came with this idea of like, yeah, line is going to be everywhere, but if you want to track where this map, how this map is flowing through the code, and so to try to figure out what is smashing our line, we can try to add here like something like my meta true or whatever. That's going to be easier to search than trying to search for line. So yeah, let's hit record here. Now run it. And yeah, and we have a recording here. We can stop this now because we already have the recording here. So let's try to analyze this. So first, just running that, executing code in a bunch of threads, we can take a look at those threads to see what's going on. This is what I did the first time I was looking at this. Yeah, I don't know, this thread 4, it's waiting there, accepting connections or something, nothing interesting. This isn't doing much either. I don't know what this is about. More connection stuff. And this is a server loop with some HTTP stuff. I don't know, but I think everything is happening on main here. Why there are so many functions in the tree here, and not like everything is rooted like in one function? And this was weird for me the first time I looked at it. But yeah, the thing is, the REPL here, it's inside a bunch of functions and waiting for reading something for the standard input. So when we started recording and then executed something, we were already deep down a call tree, and that is why we are seeing all this stuff. But anyway, that doesn't matter. But the first thing I tried for this was to come here to the code window and search for my meta or something, and it's going to search values which are so it's going to go over all the values we recorded, serialize them, and search this my meta string on the serialization. And this is pretty handy sometimes. As you can see here, let me try to make this bigger. So you can see here it's finding on this, this is a var and contains like a string builder inside, and my meta is there. So inside some logs or chars. And yeah, we can hit enter here and keep hitting enter and try to walk over different code that contains my meta in serialization. I figured out that this was going to take a long time to because this string builder is showing everywhere. So the second thing I tried was to come back to the tree here and try to look at this thing, because this is a call to tools reader read. So this is reading our form. So I wanted to see if it's reading our form with meta or not. So here you can see this is a call to read with some arguments, and it's returning the form it read, the form we added there. So we can inspect it, and inspector is nice here because it's going to show metadata. So this is the value and this is the meta, and here we already can see an issue. So the meta map contains like my meta true, but the line is already wrong. So our line, our provided line, was already smashed. So yeah, now I want to see where it got smashed. So one thing we can do for that is try to search where this key, for example, is used. So we have this key my meta, and try to track that and try to figure out where it's the line that is next to it, it's being smashed. So for that, one thing we can do is to go to the code window here. We can search from the front or from the back for uses of that value. I'll choose to search from the back. So we move to the last recording we have, and now let's have let's bring this again, and now we are on our last recording, and we have this value on the spectre. We can click back here, and it's going to search back for this. Okay. Here we are into read delimited, and this form is evaluating to our keyword. So and it's the last time it was evaluated. Yeah, looking at this, we can click around here. For example, what are this form, for example, and we are going to see a menu. And this is because every time you see a menu is because you are inside a loop. In this case, it's this loop, and it means that this form took 4 values. And here we can see our line 42 and our meta true, which is kind of what we are looking for. And this is inside a loop, and it's adding things to A, and A is a transient, and when we finish, we are making it persistent. So this looks like a vector containing our meta. So what we can do from here, it's, yeah, let's get rid of this. We are not going to use it. Make this bigger. And now let's try to follow this thing. Where is this being used? So for that, we can click follow next, and it's going to take us to the next expression that is evaluating to this thing, which is the resulting if. Nothing interesting there. We can keep clicking. Now we are in a different function. Read map. We can keep clicking on it. Keep clicking. And here, as you can see, if we keep clicking, nothing else happens. This is because it's the last time it's finding this vector, and this is because, yeah, it's converting that to an array and then to a closure map. So yeah, if we want to keep following it, now we need to keep following this map. So let's follow it, and again, nothing else. This is because from now on it is returning this map, which is a new hash map. So let's follow that. We can keep following that. It isn't doing anything interesting with it, just returning it. And again, here we need to do the same thing. Now we need to follow this new map because it's our map, but with some extra metadata on top of it. Let's follow it. Again. Nothing interesting, nothing that had to do with smashing our line. Okay, the sugar meta something. And here it's interesting because it's the last time our map is mentioned, and it's also something that is creating a new map, and it's doing just that, like smashing our line with some line that has the value 1 and column 1. And I think here we find what we were looking at, what we're looking for, sorry. So yeah, I think we can try to fix this by changing this line. So yeah, let's get rid of that. Let's go to Emacs. Let me see where this is. And this is Tools Reader. read meta. Okay, so we can find tools reader, and here we are. Read meta had already this open. So yeah, we can try to change here by merge, and we can merge these two things here to M. And yeah, so we just with this we can give precedence to our lines and columns instead of these lines and columns. So if these are nil, we will use the original one, and if not, we replace them. So yeah, let's try to see if that fixed it. So we can try to run the original thing. Okay, now we are in a ClojureScript REPL. We can try again the thing. Yeah, let's check the meta foo now in ClojureScript, and yeah, we fixed it. Now we have line 42. So yeah, so that's FlowStorm provides a lot of features. Maybe there are other ways of debugging this and coming into this line and fixing it. But yeah, this is the way I came up with, and it worked super fast. Yeah, that's all I wanted to show. I hope that is useful to other people. That's it. Have a nice day. Bye.